Solving rational equations, just like when we added and subtracted them, involves the use of the least common multiple LCM, but you use it a little bit differently. We basically use the LCM to wipe out the denominators completely, like we would do in equations with fractions. For example, if I try to solve this equation, which is actually a linear equation because it's x to the 1, and also there are no variables or x's in the denominator, so this is not a really rational equation per se, it's just a linear equation. I would say, well, get rid of the denominators. The LCM is 20, it looks like, so I'm going to multiply both sides of the equation by 20, and in doing so, notice how the denominators wipe out nicely. And we can move on about our business solving this. So we get 10x plus 4 times 3 is 12 equals 5 times x is 5x. And then we can carry on and get what x is finally equal to. So that's negative 5x equals 12, and x is equal to negative 12/5. Rational equations are done the same way, with the use of the LCM to wipe out the denominators like we did here. So we're going to need to get the LCM and then get rid of the denominators. I also want to point out this big note that we can only wipe out denominators if we have an equation like we did here. We will not be able to use this method and wipe out the denominators if we have an expression. So it doesn't work for expressions, it only works for equations. So to solve rational equations, you want to find the LCM or LCD, lowest common denominator, first, then use it to multiply both sides of your equation with that LCM. That will wipe out the denominators and you can solve whatever resulting equation you get, whether it be linear or quadratic. Then the mandatory step 4 is that you have to check your solution in the original equation to make sure the denominator doesn't become 0 when you plug in that solution. So this is a mandatory last check for all rational equations. Okay, let's solve these two problems. First equation, again, is a rational equation because I have fractions and there's variables in the denominator. So I got to get the LCM first, and the LCM looks like I'm going to need an x for sure, and then the 3, or better yet, even the 15, because the 15 contains 3 as a factor. So the LCM, the big bag that contains all the different denominators, is actually 15x. 3x is inside of 15x, x is inside of 15x, and 15 is inside of 15x. So I multiply each chunk, or each term, by 15x, and in the process, denominators should wipe out. So this x is gone, 15 divided by 3 is 5, this x is gone, and then the 15 is gone. So what I end up with is really 5 times 1, which is 5, plus 15, that's really a 15, times a 1, which is 15, equals 4 times x, which is 4x. So we've got 20 equals 4x, which means x is equal to 5. But now I must check it in the original denominators. So again, once I get that, I go check it in the original denominators, and they don't become 0. First one becomes a 15, second one becomes a 5. That one's a number anyway, so x equals 5 must be the solution. Part B, the LCM looks like it's going to be an x minus 2, and that's it. I don't have any other denominators. This is just over 1 anyway. So each term gets multiplied by x minus 2. And in doing so, again, my goal is to wipe out the denominators. This guy goes away completely. Nothing cancels here, so they both stay. And then this guy goes away completely. So we end up with 2 plus 2 times this binomial equals 4 all by itself. Distribute, we get 2 plus 2x minus 4 equals 4. Combine like terms, that's negative 2 plus 2x equals 4. We're going to add 2 to both sides. 2x equals 6, and it looks like x is equal to 3. But I'm not going to box it yet. Remember, I must check it in the original denominators. If I put it here, I don't get a 0. I actually get 3 minus 2, which is 1. If I put it here again, it doesn't become 0. So 3 is good to go. 3 is my solution for this rational equation. Okay, for part C, I can use the LCM, which is x plus 5 and 2x plus 1. But since I have a fraction equals a fraction, I might as well just do the cross product and set them equal to each other. So remember, I have that option. 1 times 2x plus 1 must be equal to 2 times x plus 5. So I basically have 2x plus 1 equals 2x plus 10. And then I subtract 2x from both sides, and I get 1 equals to 10, which is clearly not the case. That's false. So it leads me to believe that this problem has no solution. Remember, anytime you get a false statement in the process of solving an equation, there isn't going to be a solution to that equation. So this one has no solution. I don't have to go any further. Let's go to part D and get an LCM. Because it's not one fraction equals another fraction, I can't do the cross product business. So LCM, I'm going to definitely need a 2. That's 2 times W. I'm going to need a W. I'm going to need a 1 minus W. And then when I get to this 2, it's already in my LCM, so I'm good with my LCM. Multiply each term by the LCM, so we're essentially multiplying all numerators by the LCM. And when we do that, our goal is for things to wipe out. So these guys wipe out, these guys wipe out, and this 2 and this 2 wipe out. Which means I'm left with a 1 minus W and this 1 minus 2 and this 2W and this negative 3, the W, and the 1 minus W. So let's clean things up. 1 minus W minus 4W equals, let's distribute, minus 3W plus 3W squared. Combine like terms, 1 minus 5W, negative 3W plus 3W squared. Since this is a quadratic equation, I'm going to set everybody equal to 0. So we got to get a 0 on one side. And I'm going to put it as negative 1 for now, plus 2W plus 3W squared. And instead, in descending order, I'll look at it as 3W squared plus 2W minus 1 equals 0. Now I got to factor this, so I'm going to do the wow method we were talking about. Multiply the 3 up. W squared plus 2W minus 3 times the negative 1 is negative 3 equals 0. That's going to be factorable. Product negative 3 sum 2. W plus 3 and W minus 1. But since I had moved up the 3 and multiplied by it, let's divide these guys by that 3. And that's going to give me a reduction there, W plus 1. This guy doesn't reduce, so I move the 3 up. 3W minus 1 equals 0. So finally I have it factored. I set each factor equal to 0, and one possible answer is negative 1. The other possible answer looks like it's a third, but I must check these to make sure denominators don't become 0. So let's go up and check out the denominators. If I had W 0, this denominator would go bad. If I had W equal to 1, this denominator would become undefined and go bad. And neither one of my answers are those. Negative 1 is okay, because when I put it in here, 1 minus a minus 1 becomes a positive 2. So denominators don't become 0, and this equation actually has 2 solutions. Okay, let's solve this part E. And in order to do that, I have to factor to get the LCM. That's a quick factoring problem. X plus 3, x minus 3. So the LCM is both of these factors. I know this looks a little bit different, but remember it's just the opposite of x minus 3, and it's going to leave off a negative 1 when we cancel things. So x plus 3, x minus 3, each of these terms gets the LCM. And our goal is for some cancellations to occur. and it looks like definitely these guys go away. In the second term, these guys go away. Now be careful, in the last term, this does go away with that, but it leaves off a -1, because 3 minus x is the opposite of x minus 3. So what I'm ultimately left with is a 12 in the first term, plus a 2 and the binomial x minus 3 in the second term equals, in the last term it looks like I have a -1, an x, and also an x plus 3. Let's clean these guys up and distribute. 12 plus 2x minus 6 equals -x squared minus 3x. Combine like terms, that's 6 plus 2x equals -x squared minus 3x. Now since I like my leading coefficient to be positive, it makes it easier for me. I'm going to move everybody to the left and add appropriately. So these guys are gone. I have 0 equals x squared plus, let's put it in descending order, 5x plus the 6 last. So that looks pretty good. I can factor that, x plus 2, x plus 3, and that's going to pop out two solutions, -2 and -3. But again, I must check these to make sure the denominators don't become 0. Now watch this, when I go back up over here, when I look at this denominator, if x is equal to -3, the denominator becomes 0. That's no good. So we throw away the -3. As long as it fails one of them, it's no good. You toss it out. It also fails the first one, but that one caught my eye first. Now x equals -2. No denominators become 0 in the original equation, so my only answer here is x equals -2. Alright, part F looks like it has an LCM of 56x and the factor x plus 1. So 56, and then we got x and x plus 1, so each numerator gets the LCM, and our hope is for some cancellations to occur so that we can wipe out the denominators. And these x's go away in the first one, x plus 1's go away in the second one, and 56 goes away in the last one. So I got a 56 and an x plus 1 left. Then I have just a minus 56x left. And then in the last piece I have the x and x plus 1 left over. Let's distribute and clean things up. 56x plus 56 minus 56x equals, distribute x squared plus x. On the left it looks like these guys go away, and I'm going to subtract the 56 from both sides. That's going to give me the 0 I need equals x squared plus x minus 56. This guy is factorable, that's good news. X and x, it looks like plus 8 minus 7 work. So it pops out two solutions, -8 and positive 7. And again, I have to check these in the original equation denominator. So -8 going back does not make it 0. That's okay. And 7 too, if I go back into both, it doesn't make them 0. So we're good to go. Our solutions must be -8 and also 7.